Hi, Emmanuel here. Welcome again to another class. Now, this integral involves the derivative of this inverse trigonometric function. Now, it may not look like it, but it is what it is. And if you know your standard derivative of inverse trigonometric functions, you will not be in doubt. Now, let's get into the class and talk about this. Welcome again to another class. Now we have this simple integral to solve. I want to put this into clear perspective. We can rewrite this integral as integral cos inverse of x multiplied by minus 1 over root 1 minus x squared dx. Now, this is basically what you have here. Now, if you still remember your standard derivatives for inverse trigonometric functions, you know that this is the derivative of this. Because if you have the function y is equal to cos inverse of x, what this means is that x itself will be equal to cos y. If y is equal to cos inverse of x should be equal to cos y. So the x dy, if we differentiate this now, the x dy will be equal to minus sine y. And then dy dx, which is the inverse of this, will be the inverse of this. So we'll have minus 1 over sine y. Now, having this in mind, remember this trigonometric identity, sine squared y plus cos squared y plus sine squared y is equal to 1. Now we are targeting this, so we can say that sine squared y is equal to 1 minus cos squared y. Now remember that x is equal to cos y, so cos squared y will be equal to what? X squared. So have sine squared y is equal to 1 minus x squared. 1 minus x squared. So if we take the square root of both sides, we'll have sine y will be equal to square root of 1 minus x squared. That's that. So having this in mind now, we know that dy dx is equal to minus 1 over sine y. So this derivative boils down to minus 1 over sine y is equal to 1 minus x squared is equal to root 1 minus x squared. And this is what we have here. So this is the derivative of this, as we can clearly see. So what do? I say let a be equal to cos inverse of x. Now if a is equal to cos inverse of x, therefore the a dx will be equal to the derivative of this, which is this, equal to 1 over root 1 minus x squared. Therefore, the a itself will be equal to minus 1 over root 1 minus x squared dx. If we multiply both sides by dx. So we have this now. So this integral can be rewritten as the integral of a. A is equal to cos minus 1, which is this, multiplied by dA, is equal to this. This is what you have here. So have this integral. So to solve this integral now, have a squared over 2 plus c. Now this is the solution. So if we just input what we have here, a is equal to cos cos inverse of x. So the integral itself now becomes cos inverse of x squared over 2 plus c. Is this simple enough? I think it's simple enough. Keep solving problems. Don't run away from them. Until next time. Bye bye.